Ladies and gentlemen, welcome to FameLab South Africa. This is our final event, and this is the 10th season of FameLab South Africa. Our partners, of course, NRF SASTA, which is the South African Agency for Science Technology Advancement, and then Jive Media. We've gathered here because we are celebrating young people, specifically your ability to get your message across. So today you will be judged on 3 categories. We will be looking at content, we will be looking at clarity, and we will be looking at your charisma. Each one of you will have 3 minutes, and we have 10 finalists that are joining us live on this Zoom session. Of course, you would know that the winner of this round, our final event, will later on participate in the international event, which will happen on the 25th of November. For that purpose, we have lined up 4 great judges, people with expertise and knowledge in the game of science communication. So allow me to briefly introduce our judges to you. Our first judge for 2022 is Ina Smith. She's involved in promoting digital skills, instructional design, working on things like open access, open science, and open data publishing in the global south, with a specific emphasis on Africa. She holds a master's degree from the University of Pretoria in computer integrated education, and she's currently employed as the project manager at the Academy of Science of South Africa, where she manages African Open Science Platform. Welcome to you, Ina. Our second judge for 2022 is Tshiamo Legoale, an undergrad in geology, but she's got a master's in environmental management. She's worked in the mining sector, where she focused on small-scale mining communities and technology development and transfer to marginalized and disadvantaged mining communities. She currently holds a position as social manager for the Trans-Caledon Tunnel Authority, where she looks into things like social impact and stakeholder management. But what is most impressive is that in 2017, Tshiamo was the South African winner of FameLab, and she then went on to become the international champion for that year. So she's got the stuff, she knows what she's talking about, and she will be able to guide you as our participants this morning. So Tshiamo, welcome to you, and thank you for agreeing to be a judge this year. Then our third judge is Wiida Fourie-Basson, who is a science writer for the Faculty of Science at Stellenbosch University, and she's also a specialist lecturer in science journalism. She holds a master's degree in communication, and if that is not enough, she is now pursuing a second master's, this time round, in environmental philosophy. Her motto is simple. She says, if I can't understand the science, then nobody else will either. So hopefully you will be able to impress Wiida this morning. Wiida, thank you for agreeing to be part of this process, and thank you for your assistance in selecting the winner for 2022. And then last but not least, the only thorn amongst all the roses is Sibusiso Biyela. He is a science communicator and has been writing for science, specifically for more than 11 years. And his latest interest is in decolonizing science using African languages. And he's also the co-producer of a science podcast about science presented in isiZulu. So what must I say? Ngiyabonga or siyabonga? Is that right? Sibusiso, thank you for joining us, and thank you for your input. And we know that our participants will, bear great fruits from interacting with you. So here we are celebrating you, we are celebrating your ability to communicate science, and we know that it's important for us to do so. I'm reminded of a quote by a guy called Robert Meehan, which said, our learning, or maybe I should rephrase and say our education, becomes relevant when we are able to connect it to reality. And I think we know that you guys are clever, we know that you are specialists in your respective fields, but if you are not able to talk about what you do in a way that other people understand, then obviously you are unable to think about your impact and how you are contributing to awareness. I'm, of course, Gillian Adrense, working for the NRF. And at the NRF, we say that we're all about advancing knowledge and we're all about inspiring a nation. But we can't do that if we are unable to take people with us. So thank you for being on this ride with us, and thank you for sharing your talents, your skills, but also thank you that you are willing and able to communicate your science in a non-specialist way. All right, ladies and gents, before we get to the action, allow me to create an opportunity for our country partners to share a couple of words from their perspective. So firstly, I would invite to the stage the Managing Director of NRF SASTA, that's the South African Agency for Science, Technology and Advancement, Dr. Nompumelelo Nkosi.
Good day. My name is Nompumelelo Nkosi, and I'm the Managing Director of SASTA. I'm very excited to be here to welcome you to the finals of FameLab South Africa 2022. We've been in this journey since 2013, and needless to say, we as SASTA are very excited to still be here. So I went to an event, and during lunch, I got an opportunity to randomly sit to a young lady. And as we were introducing ourselves, I told her who I am. In fact, no, I asked her first who she was, and she told me who she was. And I asked her, so what do you do? She told me, no, I'm actually doing science communication. Needless to say, I was very intrigued. How could it be that I happened to just sit to a young black lady who is talking about science communication? Lo and behold, this lady told me that she was SA 2020 winner. Her name is Pinky. I was so excited. And for us to be here today, to be having the finals for FameLab South Africa 2022, for me just shows that this competition is actually yielding its results. What we aim with this competition is for us to develop science communication skills in particular. As scientists, engineers, technicians, mathematicians, innovators, we go to school, we learn the core of our subject, we come back, we do our work, we're very good at what we do. However, oftentimes we're not able to communicate the science to the people, yet we want the very same people to understand, to appreciate, and to take up the work that we're doing, but we fail to communicate it to them. So through FameLab, we capacitate scientists, engineers, we call them STEM professionals. We capacitate them with science communication skills. We give them the required skills in order for them to be able to talk about their research in a way that a gogo in Kalabucha or Nkhono in Kalabucha is able to understand what it is that they are doing. And needless to say, the more we do that, the more the general public will appreciate the good that we're doing as a country and also understand and appreciate the benefits of science. The more we get the community and the general public understanding and appreciating science, the more we get buy-in from them. And who knows, even the investment in science will increase. So I think that's basically the long and short of why we are doing the FameLab competition as SASTA, why we are supporting it. I must say also, it is very interesting to look back and see the winners of the previous years. To be able to sit next to a young lady from a rural area in Northwest who has now been, who has won a competition and is able to communicate their science, clearly it shows that we're doing something well. It actually shows that we are meeting that which we sought out to meet when we started this competition. And I'm excited about today. I know that the winner of today would represent that very young person in South Africa who's doing very good science, engineering, innovation, and is able now to communicate it to the general public. I would like to thank our partners, our hosting institutions from universities to centers of excellence. We wouldn't have done this without you. And I hope that we'll continue with these partnerships in years to come. I also like to thank Jive Media South Africa for going this journey with us. And also I'm hoping that the relationship will continue. Lastly, to our finalists, you've come far. You've done well. You are winners already. The one who will represent you today does not mean that he or she is better than you. It just means that today it was his or her day. But all of you, the mere fact that you made it this far tells us that you've done well. I hope that, like Binki, who is continuing with communicating her research to the general public, I do hope that even you guys today, you will continue doing so. It's not about the winner, but it's about the skills that you've acquired through this competition. Have fun. It's about having fun as well as you communicate your science. I'm looking forward to seeing and watching your rendition today, and I'm looking forward to even celebrating the winner. Good luck. I hope you have fun. Enjoy your day. Thank you.
Thank you, Dr. Musia, for those words. Let me now invite to the stage the Research Engagement Specialist and Director at Jive Media Africa, Mr. Robert Inglis.
Greetings to you all, and may I say what a great privilege and pleasure it is to welcome you to this, the 10th FameLab South Africa final. When we started this competition in South Africa 10 years ago, we could not have imagined how successful it would be. And over the last decade, we have partnered with so many of you, science councils, research chairs, centers of excellence, and of course, institutes of higher education across the country. And we've had a wonderful opportunity to meet literally thousands of young researchers through these hundreds of events. We're living at a time when science is acknowledged as a critical component in helping us to achieve the Sustainable Development Goals and in solving some of the greatest challenges of our time. But science cannot solve challenges if it stays in the lab. And we can't solve challenges collectively if we aren't able to communicate with one another and share ideas. We have this opportunity to cause massive positive change and to avert the negative impacts of so many of us living on the planet. But for that, we need to communicate. We need to share ideas with one another. So how does FameLab contribute to skills development for young researchers? Well, in our experience, it gives them, firstly, the awareness of the importance of communicating science. Secondly, some insight into structure about what works and what causes impact in communications. Thirdly, it gives them confidence. It gives them confidence through the act of actually standing up and speaking to be able to go out into public spaces and communicate. And finally, it makes them part of a larger network, an international network of scientists who are passionate about communicating their science. We'd like to take this opportunity to thank the South African Agency for Science and Technology Advancement, SASTA, which is a business unit of our National Research Foundation, for this ongoing partnership, which since the very first year that we ran FameLab has been a constant support. We could not have done this without you. We could not have achieved what has been achieved without your support. And we'd also like to thank all of the host institutions. The host institutions in each of the faculties around the country, in departments and councils around the country, are those people who are close to the researchers themselves. And your interest and care in supporting those researchers is invaluable. Finally, our very best wishes and huge congratulations to all of the contestants. You have risen to the challenge, and each of you has succeeded in telling amazing and inspiring stories about science. We commend you, and we know that you will go on to become engaged researchers who acknowledge the value of making science a collective exercise with and for all life on our planet. Thank you and good luck.
All right, thank you, Robert, and thank you for being our partner on this journey. So let's get the show on the road. So we are ready, the stage is set. So I think let's get our show on the road. So each one of you, as you know, would get 3 minutes for your presentation. And after your presentation, there will be 2 judges interacting with you to give some comments and then also to ask some questions. So let me call to the stage then our first participant for 2022. And our first presenter is Onesimo Mtintsilana. I hope I have that correct. She is a high energy physicist working on a PhD and experimenting at a place called CERN, passionate about science communication And she's as passionate about science as she is about walking in the mountains, which is something that you love to climb. Ladies and gentlemen, let's welcome to the stage our first presenter for 2022, Onesimo.
Did you know that every time you eat a banana, you might expose yourself to antimatter? A banana produces one antimatter particle every 75 minutes. What am I talking about, you may wonder? Well, meet matter, and it's almost identical to antimatter. Now, you see, matter is everything we see around us in the universe, including ourselves, meaning we can see matter, touch matter, or even taste matter. What about antimatter? We see absolutely nothing built out of antimatter. Actually, very few people even care. So, does antimatter really matter? Absolutely, because you see, antimatter is so confusing for many scientists. Sometimes we look at it and we think it's matter until matter creeps in. These two are not compatible. When they meet, they start to fight each other to a point where they mutually destroy one another, leaving only nothing but light. Hold on now. I told you a banana has antimatter, didn't I? So why are we not getting destroyed by bananas? Well, a banana only produces one antimatter particle, meaning it is not enough to destroy us. Wait, things are getting confusing because when the world was created, there was equal amount of matter and antimatter, meaning that somewhere they should have met and potentially destroyed the universe. But that is not the case. And that is the question we are asking ourselves as scientists every day. Why are we still living? And maybe the answer to that question lies with antimatter. Hold on, where is all the antimatter? We can't find antimatter anywhere in the universe. But here at CERN, the biggest particle physics lab in the world, we are now making antimatter because we want to be able to give answers to questions such as, where exactly is it? And why did it run away from us when the universe was created? But to make things even worse for us, a famous celebrity in science, Albert Einstein, tells us that, well, whether matter or antimatter don't look alike shouldn't really matter when you expose them to what we call gravity. Now, gravity causes matter to fall down, meaning that antimatter should also fall down. But will it? What if it goes left? Nobody knows. But in the next couple of months here at CERN, we will take all that antimatter and we will expose it to gravity for the very first time ever in the world. Stay put. And maybe, just maybe in the near future, we might be able to tell you just how good friends or really bad enemies matter and antimatter really are. Thank you.
Hi, Onesimo.
Yes.
That was a very great presentation. I thought you were a fantastically high energy physicist. So thank you very much for that. So a question I would like to ask you is, with the experiments that you are working on at CERN that you'd be doing, are you actually going to see antimatter with your eyes? Like, are you going to produce some, or is it going to be signals or something like that? And how exactly does that work?
So we're never going to see antimatter with our naked eye because this is at microscopic level. It's we are currently making antimatter, so it's simulations where it's like we have really powerful microscopes that are able to see the antimatter that we have created. So it's impossible for us to see any antimatter because we are zooming in. It's like if you take one strand of your hair and you zoom in more than 200 billion times inside it, so it would not be possible for us to see it. It's basic simulation. Thank you.
Thank you.
Thank you, Onesimo. That was brilliant. I really liked your talk and the way you took something that I don't think I ever understood.
Well, we also don't understand it.
Yeah, I know, but it's physics. It's like you understand it for a moment and then it disappears, like antimatter, I think. But you did really well in terms of how you visually portrayed it. I really appreciated that, and the use of your voice as well, in how you use your voice to talk about these intricate things. I sometimes just wish you could maybe just stop before you take a breath before you go on to the next sentence, so I can get it. Like, what did you just say? And that there's a moment that it can sink in, because these things that you're talking about is like, the big universe. And then you really did it really well. I want to know whether you are in any way otherwise engaged with science communication activities at CERN, for example.
Yes, both at CERN and in South Africa. At South Africa, I'm the student representative for the Women in Physics. At CERN, I do a lot of lab tours every day. After this, I have to go to give a lab tour. So I'm very much engaged with science communication. And in November, we are having a festival in Geneva for just scientists. So I'll also be working on that.
Okay, fantastic. No, thank you very much. I enjoyed that. Thank you.
Right, thank you to our judges on the Onesimo. Thank you very, very much. There we had matter, antimatter, almost traveling at the speed of light. Right, so let's move to our next contestant for 2022. Next up, we've got Ewura-Esi Manful. She wants to bring hope to drug-resistant TB patients. She's a master's student in molecular biology and an enthusiast that hopes to identify new treatment strategies in the fight against TB. Ladies and gentlemen, let's welcome to the stage our second contestant.
How many of us here can attest to the fact that familiarity distorts healthy relationships? Yes, it really does. And the same can be applied to treatment to infectious diseases. Over the years, we have seen an evolution in the treatment of diseases because pathogens, which are disease-causing organisms, have become too familiar with the treatment available. As a result, they do not respond to the terms of treatment. They bully medications, interfering with the health of you, and you. And unfortunate ones lose their lives. This same phenomenon exists in the treatment of tuberculosis, with millions of lives lost every year. It is staggering and sad if you take a look at the numbers. Patients are exposed to multiple antibiotics for at least 6 months, which even have side effects. The traditional way of fighting against tuberculosis has always been pathogen-oriented, that is, targeting the pathogen directly. However, this is becoming ineffective as the pathogen have evolved and developed adaptive strategies to escape the body's defense system and also to defeat drugs available, leading to antimicrobial resistance. Antimicrobial resistance is a global health crisis spreading faster than ever before. You will all agree with me then that this calls for an intervention as these smart pathogens evolve and adapt. And that is exactly what my research seeks to achieve. We want to evolve with the mycobacterium. And as scientists, we know that this is more than possible. Contrary to the pathogen-directed approach, my research seeks to target the body's defense system by improving on it to be able to fight against mycobacterial infections. This strategy is called host-directed therapy, or HDT. The host, that is you, proactively make use of its own body components to ward away these pathogens. HDTs can change the local environment in which the pathogen exists to make it less favorable for it to live and grow. So far, we have found that when we infect human cells in the lab with a mycobacteria, a dormant component in the human cell, when enhanced, can effectively restrict bacterial survival. As such, I will be studying the role of this particular component, which will enable us to devise new treatment strategies to fight against tuberculosis. The implications of my research will shorten the duration and number of drug intake, enhance the body's ability to defend against these pathogens, and above all, save millions of lives of people. Now imagine yourself having a mechanism that keeps your relationships healthy. This is how I would like you to live and think about HDTs and its positive impact on tuberculosis. Thank you.
Thank you so much, Ewura. I really enjoyed that. I loved your energy, and I love that you started off with a question. because it kept me interested. And I was literally glued to my screen as you were talking. So thank you very much for your talk. Just a quick question. The type of treatment that you are exploring at the moment seems to be targeting the environment around which the pathogen exists instead of the pathogen itself. Now, in terms of time to heal or to completely destroy the pathogen, is it slower or faster than the conventional treatments that we have?
So this is a method that is actually gaining traction. And so far, what we've realized is that it's a faster approach, but in as much as it's killing the mycobacterium, it is not going to kill it completely. So we are sort of going to use it in conjunction with some of the antibiotics that are currently working.
Oh, okay. All right. Thank you so much for your talk. Again, I really enjoyed it.
Thank you, Ewura-Esi. You're truly passionate about what you talk about, and you know your subject very well. So well done and congrats to you. My question relates to, as you've mentioned, there are many incidences of tuberculosis, people dying. What do you need to accelerate your research? What would you say, if you had a wish list, what would you put on that wish list?
My wish list would basically be able to get in touch with patients and encourage them that we as scientists, we are doing our best and there is hope for antimicrobial resistance.
Thank you very much.
Right, thank you very much. Thank you very much, judges, for your feedback. So from tuberculosis, let's go to our next contestant for 2022. From the Tshwane University of Technology, we have Nompumelelo Nkosi. She's a master's student in applied science horticulture and believes that the fruits of her research will yield economic growth and development opportunities. Her current research focuses on nutritional and phytochemicals composition of selected indigenous fruits from Limpopo. So let's sit back and let's listen to some fruit for thought.
Allow me to take you back to the ancient times of our forefathers. Back in the days where the African population relied on indigenous fruits for survival. Fruits such as marula, black monkey orange, and milk plum were a source of nutrition and medicine. But over time, all of that has changed. The introduction of exotic fruits in the African continent has resulted in the shift from indigenous fruits to exotic fruits as a source of nutrition, resulting in making indigenous fruits seem less significant. In spite of all of that, there are many communities in Africa, especially in rural areas, that still rely on indigenous foods for nutrition, as well as medicine and income generation. These indigenous foods are collected from the wild and are sold by the roadside. And different products such as juice, jams, jellies are made from these indigenous fruits. Even though indigenous foods contribute to the country's economy, there's still a low state of commercialization. Now, my research study focuses in bridging the gap of knowledge by profiling the phytochemicals and the micronutrients in 10 selected indigenous fruits from the Limpopo province in the Vemba district. Now, what are phytochemicals? Phytochemicals are bioactive nutrients that are found in fruits and vegetables that provide health benefits to reduce the risk of chronic diseases such as cancer and diabetes. And on the other hand, the micronutrients are vitamins and minerals which are essential for health development. Now, in simple terms, my research analyzes and quantifies the different bioactive compounds that are found in food, indigenous foods, so that we understand what is in these foods and how do they relate to our health. The aim of this research is to contribute in ensuring that indigenous foods are included in the National Food Database System. Such inclusion will help consumers in identifying the indigenous foods that they can enjoy and that have health benefits, and also encourage the food industry to utilize indigenous foods as functional ingredients for product development. The broader aim of the research study is to encourage and promote the commercialization and domestication of indigenous foods. Investing in indigenous foods will yield great benefits such as ensure food security as well as poverty alleviation through job creation and environmental sustainability, making sure that our indigenous flora does not become extinct in the future. Thank you.
Thank you very much for that, Nompumelelo. I was very happy to hear everything that you were saying about your research, especially about the use of indigenous foods. I think it's quite important to look into that and to also standardize them with the food registry that you were talking about. So a question that I would like to ask you is, since you're dealing with indigenous foods and such, have you or are you planning to engage with local communities, such as in the study area of the Gambia district, in terms of letting them know about the nutrition of the food that they're eating, or to encourage them to eat more of this food? What are your plans around that if you are going to do that?
Okay, thank you for the question. Firstly, I have engaged with the local communities in terms of understanding the different indigenous foods that are available in the Limpopo province in the Venda district. And in terms of going back to the communities and also sharing the information, we are planning such an outreach to also to go back to the communities and collaborate and inform the community members about such in the importance of the nutrient composition within these indigenous foods. Yes, we are planning something like that as well.
Thank you.
Thank you.
Thank you, Nompumelelo. That was a lovely talk, and it's a topic that's very close to my heart. So thank you for that. As a science communicator writing for Stellenbosch University, I'm like immediately want to jump on you, get the story, make a video and put it out there so that people can take note of it. So I hope you have good science communicators at your university. And if you don't have somebody, please contact me. This is such an important topic. It touches so many things. And you mentioned that in your talk as well, from job creation, food security, environmental sustainability. I thought about climate change as well, whether these indigenous foods would be more resistant or, than the exotic foods. But the question I actually want to ask you is, where did this interest come from originally? What motivated you to go into this direction of research?
Okay, specifically, my previous qualification, I was focused in broccoli. So finding about phytochemicals and the impact that they have on our health, it sparked the interest. But like now when I engage with my HOD professor, and she directed me to the professor who deals with indigenous foods, Prof. Sibaguma. And Prof, she specifically focuses a lot on indigenous plants, both vegetables and fruits. And when she introduced the idea that I can look into indigenous foods, that sparked the idea. And I think this research was very important to me because I'm from a township and I was not well informed about these foods that are so available and provided by nature that we don't know of. So it was a huge learning curve for me as well to learn about the value of our indigenous foods. So
okay.
Yeah, that's how the whole
fantastic. It's a very nice journey. Of discovery, and then you bring this very, looking at the phytochemicals, the very, very hard science behind this. So I really enjoyed your talk, and good luck with your research.
Thank you so much.
Right, thank you, Nompumelelo. I think you have given the judges a lot to chew on as they think about the kind of scores that they want to give you. So from the Tshwane University of Technology, let's move to the University of Stellenbosch. And our next participant is Tanya van Aswegen. Tanya is a PhD student that looks at the early relationship experiences of children and how this influences brain, social, and emotional development into adulthood. Ladies and gents, here is Tanya van Aswegen.
Peekaboo. What if I was to tell you that a simple game of peekaboo can change the world? Would you believe me? Well, today I'm here to tell you why you should. Thanks to scientists, we know that the first 5 years of a child's life is the most important for a healthy development, especially for the brain. Now, how can parents and caregivers support healthy brain development in children? It's quite easy. I'll share the 3 secrets: connection, often, and early. So why is it that simple? Children are hardwired to seek out meaningful connections. If parents respond appropriately to these behaviors, connections and secure attachments are formed. Secure attachment sets up a child for a successful adulthood because children learn very valuable skills and lessons. Emotion regulatory skills and stress regulatory skills are some of the most important skills that children acquire when they are securely attached. Wow! Now that was a mouthful. What does that actually mean? Emotion regulatory and stress regulatory skills mean that children will respond adaptively in stressful and emotional situations. Also, where the brain comes in is that securely attached children will form many brain connections because they actually just experience the world better because they feel safe and have varied experiences. Got you. So, in the famous words of 2020, Tanya, you're on mute. Some children go through their whole life just like that. Muted, no response, no connection. That's why I'm here today, to create awareness around secure attachment. Now, you might ask me, where does the simple game of peekaboo come in? Well, the game of peekaboo builds memory and trust is a very important building block for secure attachment. So it's not just a simple game, but it's a game changer for a mentally healthy future for our children.
All right, thank you. That was the input from Tanya. As we said, she's unable to be with us. But again, challenging us to think about things. I remember when I was a child, we used to have the saying that said, children should be seen and not heard. But Tanya has just challenged us to think about how do we intentionally develop young kids, and how can some of these games that we play actually become game changers in terms of growth and development. So thank you, Tanya. So next we move to the Nelson Mandela University, and our next presenter is Nehemiah Latolla. He seeks to discover novel chemical compounds from plants that can be used as medicine, and believes that storytelling, specifically indigenous stories, might hold the key to unlock some of these secrets. I know that there are certain things that we can smoke, but maybe there's some other stuff that I don't know about yet. So ladies and gents, welcome to the stage, Nehemiah.
I, like many South Africans, have been introduced to the healing ability of plants through a dreadfully bitter mixture. I recall one such incident where I, snotty-nosed, inquired from my grandmother about the contents of said mixture, to which she simply responded, Wilde aus, a wild bush that cured all. This is where my whirlwind journey with phytochemistry started, which is concerned with the study of the chemistry in plants, particularly those used in the treatment of diabetes. Now, one such candidate is Cisampelus capensis, growing exclusively in South Africa, and it has been recognized as an important plant to the Khoisan people, where its leaves are used as poison in hunting, and its stems is used as life-giving medicines. Now, as a phytochemist, I must admit that my interest in the chemistry of this plant is towards drug discovery. Now, drug discovery in phytochemistry can be understood by imagining the mining process of panning for gold by the river Brook. Now, gold panning involves 3 simple processes, where you draw a mixture from the river floor, you sort through the contents, and finally isolate precious gold particles. Similarly, In my research, we extract a mixture from Cisampello stipensis. This mixture contains what we call phytochemicals. Now, phytochemicals are simple or complex chemical structures produced in the plant to ward off illness or threat. Now, the mixture then is sorted into the various phytochemical groups, where these are isolated from precious drugs for the treatment of diabetes. Now, one such candidate is pronuciferine. Now, what is interesting about pronuciferine is that it can be either life-threatening or life-giving based on its shape. In its bent shape, it is poisonous. However, in its folded shape, it is a life-giving drug and possible candidate for the treatment of diabetes. This is the wonder of phytochemistry. And what does this mean for you? Well, this situates the rich gardens of Africa as sites for innovation, investment, job creation, and finally, poverty alleviation. So while I recall that dreadful mixture, I'm enthused by what the future holds in the rich gardens of Africa. Thank you.
Thank you very much for that wonderful presentation, Nehemiah. So I am quite amazed at your explanations, the use of your props. I did not know that a simple folding of a phytochemical, as you mentioned, could change whether it's a poison or a drug. And I love your explanation of how drug discovery works, that you look for these active ingredients, if you call them that, until you find what you're looking for. I love how you compared it to gold panning. I thought that was quite wonderful. So just as what I'd like to know from you is your involvement in terms of the phytochemistry as the drug discovery that you do. Do you go all the way to commercialization, or do you usually hand that to someone else? And where does the ownership end up? Sorry, that's two questions, but sort of where does that journey go as for you personally?
Well, as you can see from my presentation, I'm very excited by this topic. I think I started this research in my PhD, and now as a postdoctoral a fellow at my institution, I'm still looking at where we can take this further. So I'm at the step where I have isolated these novel phytochemicals. Now we are looking at how we can synthesize this or create derivatives that could possibly have even better results. Also, when we think about sustainability of the environment, and then finally, we want to move maybe towards commercialization. These, of course, are big projects. They cost millions and millions of rands. But if we do get to that step, I think it is important to always recognize the community where this knowledge comes from, particularly the Khoisan peoples, the first peoples that introduced me to these plants. I would give back to them, and I would need to find, through the bureaucracy of patents and all, find trusted partners that really have the good of these people at heart to take this journey forward. You know, I think that's the best way to go about it. Thank you very much.
Thank you very much.
Thank you, Nehemiah. I really enjoyed your talk. I think you're a natural science communicator.
Thank you. Thank you.
And I agree with everything that Sibusiso said in terms of your storytelling and the use of things that people are familiar with, like horrible, dreadful medicine from your grandmother and the gold panning. That is such excellent examples to explain a complex the complexity of your research. I also love the way how you bring all the real Africanness into this, proudly South African vibe into your talk. I really enjoyed that. I want to know, are you, because this is it's so important to communicate about this, but also, as you said, the bureaucracy with commercialization and finally taking that knowledge and that research to something that is going to be finally in a product. In terms of science communication, where do you see your biggest challenges then in terms of talking to funders, or I'm just curious because you really have a good skill in talking and communicating, but you face a battle, I think, as well.
Yeah. One of the common challenges that we get is pushback from communities that we're trying to engage because of the history that this type of work has related. We know in South Africa, we have the famous rooibos bush, and these knowledges comes from communities that they have been taken and they have been forgotten in the aftermath of all of this. So I think it's just building positive relationships with the community. It is involving them around every step of the way. I see the process of science as engagement and collaboration. I always say that as scientists, we can create wonderful products, but if they're not contextually relevant, what of them? So by engaging with the community, this can definitely be taken forward. In terms of funding, like you know, we are all about how we can reach our sustainable goals. This year is the International Year of Basic Sciences towards Sustainability. And I think it is a wonderful opportunity for us as basic scientists, like chemists, to engage with funders, to engage with stakeholders, to engage with the community, to bring forward these messages, which are truly messages of hope, I think.
Thank you very much, and good luck with your research career, and I'm looking forward to the end product. Thank you very much.
Thank you very much.
All right, thanks, Nehemiah. So from plants, where we use chemistry to get from plants to medicine, now let's stay with the medicine theme and let's go to the Institute of Infectious Disease and Molecular Medicine at the University of Cape Town. And standing by, we have Sohair Geyer Benjamin. She uses her background in neuroimmunology to look for ways to treat a fatal form of TB and believes that as a PhD candidate, that sharing scientific knowledge outside of academia actually has the power to lead innovation. So ladies and gents, let's welcome to the stage, Sohair.
Today I'm going to begin by taking you back, all the way back to ancient Egypt. The ancient Egyptians believed that the heart was the hub of a person's thoughts, the source of human wisdom, memory, emotion, and the personality itself. During mummification, brains were removed because they didn't think it was essential and therefore not necessary for the afterlife. Today, we have a better understanding of the brain's importance and why there are so many effective barriers in place to protect it. Despite this, various infectious agents, such as viruses and bacteria, have developed methods of breaching these barriers, often having chronic implications or proving to be fatal. Bacterial infection of the brain is very threatening in terms of disease severity, particularly in developing countries. Now, living in South Africa, many of you will be familiar with TB, which is caused by a type of mycobacteria and generally presents as an infection of the lungs. In its severest form, it can, however, progress to the brain, leading to long-term complications and sometimes even death. Our most vulnerable population, young children and people living with HIV, are the ones that are most at risk. But our body does have its own defense force, and this is known as our immune system. And it is made up of specialized cells which actually fight off infection. Our brain contains these cells too, but there is one really underappreciated cell in the brain, and these are known as astrocytes. Now, astrocytes are star-shaped cells, and they have mainly been acknowledged for their role in maintenance and support. Increasing evidence has shown that they also play a role in protecting us. The purpose of my research is to investigate the role that astrocytes play during TB infection of the brain. Thus far, I've shown that they release tiny molecules which actually activates the immune system to help it fight infection. But whether this reaction is beneficial or detrimental to the individual is yet to be determined. By identifying astrocyte activity during TB infection of the brain, proper intervention strategies can be developed for enhanced treatment and essentially better patient outcome. I am confident that we are en route to understanding these cells better, and eventually, just like an Egyptian mummy, treatment will be a no-brainer. Thank you.
Thank you so much, Zoe, for that great presentation. And thank you very much for the analogy of the Egyptians and the mummification process. But it also spiked a question in me. How do you get these astrocytes? Do you synthesize them, or have you copied what the Egyptian did? Do you remove people's brains?
So the thing is that you do get cell lines which are immortalized cells, such as astrocytes, which you can use. However, we don't use that. We actually use real brains, and we actually use mouse brains. So we retrieve the entire brain from the mouse, and we harvest the cells and prepare them to culture them for use. There are people that do also use fetal brain tissue and brains from tumors that they retrieve during surgery in children. But yeah, we don't use that. We only use mice.
All right, thank you very much.
Sorry for the animal lovers.
Thank you, Zaire, for an excellent talk. I can just continue listening to you. You born storyteller, really. And I did not know that TB can also lead to infections of the brain. So this was really news for me. I loved how you used your facial expressions to get the message across, and your hands and that muscle movement to demonstrate the immune system. It was truly very effective. I want to ask you a question, and it's something I've picked up from a presentation by Professor Jonathan Jansen the other day on COVID-19 and the interdisciplinarity between the natural sciences and the social sciences or humanities. In your view, the work you do, does it exist in isolation, or is there some interdisciplinarity with the social sciences, the humanities at some point? I would love to hear from you. Thank you.
Okay, so in terms of interdisciplinary, I mean, my work alone is interdisciplinary because it covers neuroscience and it covers immunology. And personally, I believe that no science is isolated to its particular field because it crosses all entities. I mean, on a social perspective, the impact of science, like I say, crosses all disciplines. And if you're looking at something like infectious diseases, it is something that impacts society at large. And that's another reason why, for example, science communication is so important, because I believe that we need to start breaking down these barriers between fields and discipline and working as a unit so that we can reach different populations, reach different innovations by combining our backgrounds and our expertise in our various fields.
Thank you. I cannot agree with you more. Thank you very much.
Thank you.
Right, thanks, Zaire. And talking about science being cross-cutting, multidisciplinary in its nature, let's start with this question. Can we use mathematics to save marine life? So next up from Stellenbosch University, we have Tarryn-Lee Surajpal, and she works on computational fluid dynamics, where she uses models to simulate discharges into the ocean. Apparently at the age of 12, she summited Kilimanjaro. And let's see whether that has prepared her to get over this mountain, where she talks about her science in a non-threatening way. Ladies and gents, welcome to the stage, Tarryn-Lee.
Thomas Fuller said, "We never know the worth of water till the well is dry." And for those of us who've lived in the Western Cape between 2015 and 2017, we have experienced quite literally that this is true. The Western Cape drought of 2015 to around about 2017 emphasized the scarcity of fresh water from rivers, dams, and lakes, for example, and highlighted the need for a new, viable avenue in which to obtain water. Since we have this massive body of water known as the ocean, I would like to introduce to the stage desalination plants. Now, desalination plants are no new phenomenon, but they do not form a predominant method in which water is obtained for South Africa's water supply. Essentially, desalination plants take seawater as input and release fresh water, as well as a highly salty wastewater, or brine, like the liquid you find with olives, as output. The catch is, this wastewater is usually relatively hot and cannot be released into the ocean without considering the possible environmental effects. I mean, imagine the lobsters turning red from swimming around in hot seawater. My research pertains to using mathematics to predict the mixing and spreading of wastewater in the ocean. The spreading of wastewater in the ocean can be visualized by taking a glass of water, and a big one at that, and dropping in some food coloring. The way the food coloring mixes and spreads, where it settles, if it even settles, is what I would predict using mathematics. And this would involve creating this entire structure and everything within it using a computer. In terms of the ocean, the food coloring would be the wastewater, and where it settles would give us an idea as to which areas of the ocean are most affected by the wastewater. Essentially, this helps us to create desalination plants which have a minimal negative environmental effect, and thereby provides us with the viable avenue in which to obtain water for use during droughts or in general. Personally, after experiencing the last Western Cape drought, I certainly wouldn't mind the assurance of a fresh, non-gravelly tasting glass of water without having to haul out one of my 7 5-liter bottles stored under my bread and sent them all the way across the country. Thank you.
Thank you so much. That was quite wonderful, Joanne. Sorry, Tarryn-Lee. So I'm amazed because you were able to explain fluid dynamics, which I believe is some of the most difficult thing mathematically that anyone can do. And people always use the term rocket science and explaining something difficult. They should use fluid dynamics, and the way that you explain it now is quite wonderful, and you kept me engaged the whole time. And I love the fact that you used the recent droughts and everything to keep people engaged in such a topical thing to mention. So in terms of the applicability of your research moving forward right now, what are your next steps in applying the research that you're doing at the moment?
So in terms of desalination plants, for example, to use this kind of research, it would be, let's say, if a new desalination plant were to be built. So obviously it would ensure that the plant is built in the most environmentally friendly way, so that whatever is released from it is set to not affect the region or the water and marine life so much. So in that sense, it would be used if there was a new desalination plant being built, or it could be used to maybe optimize plants or ensure that plants that are already there, desalination plants that already exist, to make sure that the waste that's being produced and released into the ocean is environmentally friendly in the sense that it doesn't affect the marine life past a certain zone, which is allowed. So in terms of desalination plants, that's how it could be applied. Or with regards to the specific software I use, that could be taken or reviewed in terms of how valid it is and then used in future. So yes.
Thank you.
Thank you, Tarryn. That was very interesting. You are not your average mathematician. To be able to talk like this and to communicate so engagingly. There's really, you've got spirit, and you're very excited about what you're doing, and you want to share this, and it's very obvious from the way you talk and how you, and the props that you used. So I'm curious to know how you got into this topic, though. So this is like maths, but it is also concerned with the environment. You can really make a difference with what you're doing. So I'm curious, what makes you tick to bring those two together?
Thank you for your question. And so it sort of started with my honors research, and it was more on the mathematical side of things, looking at how different models use boundary conditions and whatnot. Then when I got to master's, I was lucky enough to have a supervisor who had worked in industry before and also had done research in this field. So he introduced me to this, and I was automatically quite captivated, and I wanted something that would be relevant and that could be used. So that's what sparked this research.
Can I ask I'm curious as well. You know, you used a very good prop in terms of the water and then the food coloring. But if we think about the oceans, there are currents, there are storms, there are winds. It is a hugely complicated system. How do you do that?
So the process, I like to think, is take it one step at a time. So whether you have to start with a box and you say, okay, there's water in the box and it's just staying still. So you start with that. Once you have that, and you can do that on a computer, then you say, okay, what if the water's moving forwards? And then you add that. And so you build it up step by step, because yes, there's definitely so many factors that play in the ocean. And I think you've just got to go step by step. And once you've perfected, or as you've included the previous step as accurately as possible, then you move forward. So it's just a process, and you build on from that. So even right now, I probably don't have all factors of the ocean considered in my research, but it's an ongoing process.
You make it sound so easy. I'm sure it's not.
I wish it was like that, though.
And good luck. Thank you very much for your talk.
Thank you.
Enjoyed that.
All right, thanks, judges, and thanks, Tarryn. I just loved how the judges referred to you as being average. I don't know whether that was a mathematical comment, but I'm sure that your interest in modeling probably started with Kilimanjaro, where you approximated the mountain as a triangle. So from the University of Stellenbosch, we now move to the University of the Witwatersrand, where we listen to Johanné Marais. Now, we all know that HIV is a problem in South Africa, and apparently when we think about modern antiretrovirals, the therapy offers people living with HIV a full lifestyle, but apparently there's a dark side. And this dark side is related to the fact that there might be an impact on sleep patterns. So Johanné's research looks into this behavior, and she says she is a sleep neurophysiologist and hopes to put this problem to bed once and for all. Ladies and gents, here she is, Johanné.
Something fascinating is happening in your body right now, even if it is not in your awareness. Breathing. I am a sleep researcher, and that means I place electrodes on people's brains and watch them while they sleep. The brains, not the people. I diagnose sleep disorders. Other things that I monitor are breathing patterns and blood oxygen levels. Why is this important? Well, oxygen is vital for the functioning of our body and blood. But for every 1 out of 8 people, their breathing stops and starts and stops and starts repeatedly while they sleep. This is called obstructive sleep apnea. Let me explain. Obstructive, meaning your throat muscles collapse temporarily while you sleep, and apnea, meaning a cause for oxygen stress. During oxygen stress, your body enters a fight or flight mode. How I like to imagine this is each of my organ systems is a post office, and this message of panic is desperately communicated throughout your body by sending numerous envelopes covered in as many stamps as they could find to all the wrong places. This is called systemic inflammation. This inflammation through your body can lead to things like heart disease, changes in your brain function, and can even mess with your metabolism. Now, HIV infection also causes systemic inflammation. And for some people with HIV, their treatment might increase the risk of obstructive sleep apnea beyond the 1 in 8. What? That's like putting a second post office inside the post office. However, there is an upside. Obstructive sleep apnea is treatable. The downside, treatment is expensive, and currently even diagnosis is inaccessible. But that's where my research comes in. With just a few drops of blood, I hope to organize the post office, count the stamps, and hopefully find a blood marker that can be used to diagnose obstructive sleep apnea with a simple test. Maybe this could help South African people with HIV. Breathe a little deeper while they sleep.
Thank you so much for your talk, Johanné. I really enjoyed it. Let me first say, when you started, I took the deep breaths with you. That's how engaging you were as a speaker. And every time you took a pause in your breathing, I also did that. So you had us as your audience very engaged on your talk. And secondly, I find it very interesting what your research subject is. We take sleep patterns for granted as laymen and the ordinary audience. And what we do talk about most often is whether a person snores or not. We hardly ever talk about sleep apnea. So thank you very much for that education. And also, I really appreciated what you spoke about when you spoke about systemic inflammation and the analogy of the post office and the letters being sent out. It really brought it home, and I really got to understand it a bit better. Just a quick question. The treatment that you're trying to explore in terms of costs, would it cost less than what is currently on the market, or do you envision that it will also be expensive as a form of treatment?
Thank you very much, first of all, for your feedback. I'm really grateful that you were also compelled to breathe with me, because it is something we take for granted, and it's something I'm very passionate about. So the antiretroviral therapy that already exists, while it's doing amazing things for people with HIV in terms of their viral load, it has all of these other consequences. So my research isn't necessarily looking at a change of treatment, but looking at a change for diagnostics, because there are questionnaires which can be asked to people, but has only been validated in a male Eurocentric population. So first of all, that's something we need to do. We need to know, do the questionnaires really represent the South African population, specifically Black women, because they are completely under-researched. So once we have validated that questionnaire, we can then see what the stamps look like in the blood. And if we can find a test that we can use rather than a questionnaire or this overnight sleep observation, it will decrease the price of diagnosis. That means there is more funds available within a clinical trial to supply somebody with the machine that helps with sleep apnea.
Right. Again, thank you very much, Johanné.
Thank you very much.
Thanks, Johanné. I enjoyed your talk, and I've also done one of those tests, the sleep apnea tests, and I fully agree with diagnostics around it. It's very expensive, and I don't even have HIV, so I can just imagine having to be treated for HIV, and on top of that, for sleep apnea. Gosh, it must be terrible. But anyway. It is what it is. What I want to ask you is, how far are you from finding a solution, and how far are you from having that test being launched? Once it's gone, how long will it take before the public can benefit from it? Thank you.
Thank you. That's a great question. And it's something that has really only come to the forefront of my mind most recently. I'm not super familiar with clinical trials. I've done a lot of molecular work in the past, and now I'm faced with this reality that people are living. And something that I'm really hopeful for is that this will translate quickly and rapidly, but realistically, I don't think that will be the case. However, if blood tests could be found to diagnose sleep apnea, I think within clinical trials, that will save a lot of funds. And the quicker we move through clinical trials, of course, we want to do that safely and with all risks considered. And if we can simplify the method which we use in clinical trials, I think the translatability to the broader community can happen quite rapidly. I wouldn't be able to give you a ballpark time, but I am full of hope. So I will do whatever it takes to work as hard as I need to make that happen.
Wonderful. We need more scientists like yourself. Just a last question, and it's not to cut you out or anything. I'm curious. I'm simply curious about this. Is sleep apnea something that only occurs in humans, or is it also? Can it also be found among animals? Just for interest. There's no right or wrong. I believe. I don't know. Maybe no research has been done, but maybe you know. Dogs also snore.
That's an excellent question. I'm not an evolutionary biologist by any stretch. So I would imagine that the possibility might exist, but I am doubtful because a lot of what sleep apnea, there are two types of sleep apnea. One is controlled by the circumference of your throat and your general heart health and metabolic health. And then the other one is controlled by your brainstem, which is the region that kind of sits between your spinal cord and your brain and controls a lot of sensations like swallowing, breathing, heart rate, all of these natural things that happen without us thinking about it. So I think potentially that type of sleep apnea might exist in other animals where it's more of a genetic mutation or a circumstantial mutation, but I can't imagine animals with lungs being overweight and having different fats in their body and general heart issues that might lead to obstructive sleep apnea.
But anyway, fascinating, and thank you very much. Enjoyed listening to you.
Thank you.
Right, thanks judges, and thanks Johanné for your input, prompting us to think about how we see and how we need to find new ways to see maybe earlier and how that might impact diagnostics and treatment. So from the University of the Witwatersrand, we now move to the Northwest University, and standing by, we've got Nolwandle Khumalo. And she says she is a true believer. Her current research looks at how microorganisms can help honeybees in their important task of pollinating food crops, specifically how we can protect and conserve the bees in order to improve food security. Ladies and gentlemen, to the stage I now invite Nolwandle, and she is here to be.
Well, honeybees are known to sting and cause pain, but they don't need to. They've got much more important work to do, such as making good, delicious honey. Honeybees are crucial in our lives. They're dominant pollinators of a lot of flowering plants, pollinating about 70 to 80% of all the food that we eat. And what do I mean by pollination? Firstly, when bees land on flowers, they do two things. They suck the sweet nectar, a sugary juice that the plants make that eventually turns into honey. And secondly, when bees move from one plant to the other, they collect pollen, a yellow fine powder that the plants make. From there on, the plant then uses the pollen to grow and reproduce. And if everything goes accordingly and on time, this could lead to the production of food, such as your lettuce, your strawberries, literally everything on your breakfast plate. However, that is not the only thing that is happening here. There are actually microorganisms at play here that we all can't see with our naked eye. Be it good or bad, and yes, microorganisms are everywhere. From our hands, from the food we just ate now, even the bee itself. But we have a problem here. Since the early 2000s, honeybees have been disappearing,
Millions of hives have died over the years due to the use of chemicals, pollution, just to name a few. To give context now, if honeybees were to die out, thousands of plants will die too. The food we eat will stop to exist, and this could lead to millions of us dying because of hunger. And if I may ask, is that the world you want to live in? To help save bee, as a bee researcher, this is where it pretty much gets interesting for me. My research is actually looking at isolating and identifying these good microbes. And the biggest question here is how. The idea here is to feed the bees with the microbes. And if the microbes are able to live successfully inside the stomach of the honeybees without making them feel sick, then all hail to the queen, because this would be it. This would mean now we'd use the microbes to do what? To improve the survival of the bees and also their health. This is actually the same as us humans taking good microbes, commonly known as probiotics, to keep our bodies healthier and strong. So let's gather here real quick. If the experiment actually runs successfully, this will give the bees the willpower to actually fight off against any attack that they face, but also to survive better in the environment, which means more plants will be pollinated, more food for us and the animals, and better options for breakfast. And if I may ask, that's the world I want to live in. How about you? And with that being said, let's all remember that even if they sting, bees do save lives. Thank you.
Hi, Nolwandle. Thank you very much for that wonderful presentation. I love the sound effect at the beginning, although I must admit, I am terrified of bees. So you did a great job to get me back on their side, especially since them dying means me dying as well. So congratulations on that. So my question is, I'm very curious about the specific work that you are doing in feeding this bacteria to the bees. I don't suppose you let them give them in pill form, the sort of the good bacteria that you give them. So take me through a typical day in the life of someone such as you. How do you engage with the bees, and how do you get them to eat this or ingest this good bacteria?
Okay, so first of all, what we'd then normally do is to go collect brood frames, right? Then we'll collect the frames and then take them inside the lab. And then the moment the frames, it's normally the brood frames that have the larvae inside. So from there on, we'll take them inside the lab so that they emerge in the lab. So as soon as they emerge out, we can actually take them out and put them in small cages that we actually make. So normally when they're that young, they don't fly a lot. So it's easier to actually control them. So when they're on the cages, then I think that's where the experiment starts, because it's easier then to work with them. So in terms of the microbes, it's actually it's very difficult, because one thing for sure, to get the microbes that are able to live inside the bees without actually killing them is very difficult. But the idea here is to feed the microbes to the bees in the cages. So you provide them with the bees, and obviously you'd want to provide also the carbohydrate source and also protein source for the energy. So we'll do that entire experiment for a period of about 14 days, and literally depending on whether they die or not, that's when we'll probably have an idea in terms of whether what we actually fed the bees is actually improving their health or not. But yeah.
Thank you very much for that.
Thank you, Nolwandle. That was a lovely talk. And I really enjoy how you look the part as well, from the nails to the thingies. I've worked with scientists like you before, people that are so passionate about, exceptionally passionate about what they're doing. And what I appreciate from this type of scientist is that, and I see that in your talk as well, is that you have I deliberately put in the fact that I'm wallowing in philosophy at the moment. You asked a philosophical question here in terms of what kind of world do we want to live in. And you put that question very strongly out to your listener to say, but this is what I want, and this is what my research is, because the world that we are damaging the world. So is that something that comes naturally to you, that kind of thinking in your, because usually one won't associate it with the research, with the scientist, but do you realize, is that where you come from? Is that what makes you tick? This thing, I want to make the world a better place.
I think for me, even with the research that I do, is I'm always concerned about farmers. So this also goes back to my research interest, which is agriculture. So from very young, I've seen with small scale farmers that obviously, based on the quantity and the quality of the food that they produce, they can't actually upscale it. So now you'd find that also with commercial farmers, they use a lot of chemicals to actually try to meet the demands that like the demand of the growing population. So that as a whole actually is harmful, because you'd find a lot of farmers sometimes around the area that are farming are actually inhaling all these harmful chemicals. And then at some point, they actually get sick and all of those things. So for me, it's always been about finding better solutions to what we're already doing that cannot be harmful to us, also to the animals and to the plants. So it's always been that thing of, okay, what can we do better that does not harm anyone in the environment?
Okay, that's a wonderful answer, and I wish you all the best of luck. Thank you very much for a lovely talk. I really enjoyed it. Thank you so much.
All right, thanks, Nolwandle, for that input, reminding us that bees are important, because without them, we would not be able to be safe, be happy, and be healthy. So let's move to our last participant. Number 10, of course, as I said, we are celebrating the 10th year of FameLab South Africa. And our last participant, or our last contestant, is linked to the Council for Scientific and Industrial Research, the CSIR, and I would like to invite to the stage Lehlogonolo Ledwaba. We have seen that technology is a disruptor, it's changing the way we work. People want to work remotely, but there's probably a need for us to keep a watchful eye on some of our security concerns as we think about how we use the Internet of Things. So, recently completed or received or graduated with a PhD in computer science at City University of Hong Kong. Let's welcome to the stage Lehlogonolo to be our final participant for 2022.
Hey Siri, play Crazy Frog. Okay Google, open banking app. Alexa, what's the weather? 3 simple commands allow me to take temporary control of your phone and pretend to be you, all without your permission. This is an example of 2 very common security attacks called denial of service and masquerade. While my actions were benign, our reliance on technology has us sitting on a time bomb, ready to expose an increasingly valuable resource, information. And all it would take is one dodgy email link to give me all the keys to your account. Consider, in the wrong hands, smart TVs are listening devices. Smart cameras look into our household, and location services are a 24/7 tracking device. There are many known and unknown holes in smart technologies, and allowing them unrestricted access to the open internet where anyone can do anything could lead to large economic attacks like last year's Transnet incident, or more personally, identity theft. These devices are small, easily accessible, and resource constrained, having less storage than an SD card. And as of this May, there are now 2 internet-connected devices for every living person. This is the reality of the Internet of Things. Thus, as a security researcher, we find ways to ensure that the technology that we use is as safe as it can be. By exploiting the magic of prime numbers and exponents, we develop programs that jumble your data until it's unrecognizable to someone without the correct key. a process you might be familiar with called cryptography. In digital forensics, we look for fingerprints left behind by thieves to discover who they are, what they stole, and how to fix what was broken. And sometimes, just sometimes, we put on our white hats and become ethical hackers, employing our logic and analytical skills to break the devices ourselves in order to discover any potential backdoors and holes that could be used against us. In the age of information, danger is everywhere, and people aren't always what they seem. Be careful who and what you trust online, because we're in a constant game of hide and seek. In order to stay one step ahead, beware suspicious messages, avoid public Wi-Fi, and remember, Big Brother is always watching you.
Thank you so much, Lehlogonolo, for your presentation. I really, really enjoyed the use of your costume. It actually took me back to one of the series that I liked watching on Netflix. Let me just say, at the beginning of your talk, you quite literally plunged me into crisis. When you talked about the banking app, especially, you had me sitting at the edge of my seat. I really appreciate the use of examples that we can all relate to, some of the hackings that have been done in our country last year, as well as the tips that you gave us at the end of your talk on how we can stay safe when we use the internet. Like you said, everybody has 2 or even more devices. I myself have been working from home for more than 2 years, and so I'm one of the likely victims of phishing scams or things of that nature. Just a quick question. On the systems that you are researching or trying to develop, I understand that they mess around with your data so that it becomes unrecognizable to people or systems that are not yourself. Now, can't the hackers or the bad guys use the same thing to sort of mask who they are? Can they not use the same programs or systems to hide their identity? And if so, how can we protect ourselves from that?
Thank you very much for your question. So in the process of cryptography, you have 2 keys that you use. Well, in the terms of public key cryptography, you've got a public key that is available to anybody, and this is what they would use to basically unlock your message. And then you have your private key, and this is the key that you keep secret and basically ensure that no one knows what it is. So when you encrypt a message, no one else without your private key will be able to repeat that encryption. So even if a hacker was to send an encrypted message, there would be no point because only they would be able to do that. So it makes them more easily identifiable because your public key is known. Your public key is associated with your particular identity. So by employing cryptography, they're basically snitching on themselves because only their public key would be able to unlock that message. Yeah.
Oh, all right. Thank you so much, Lehlogonolo.
Sorry, Lehlogonolo, this was fascinating. And I could not help to think, gosh, did one of the anonymous group became public or what? When you put on your mask, you looked like just like one of them. So who knows, eh? But please, digital forensics, what a fascinating field. And there must be such a huge demand for digital forensics people working. The increasing digital crimes going out there on the Internet of Things, etc. So please tell me, can hackers also be used to do good things, or are all of them bad? And why do you have to become a hacker yourself? Or how do you know how a hacker thinks? Do you get what I'm trying to ask? Yes, do you have to become a hacker yourself to understand how they think? And are they all bad, or are some of them real good, doing good?
Thank you. So actually, the white hat is a type of hacker that is employed. So they're the good hackers. So those are the people that you would employ in your company in order to do various tests to check the strength of your security. Sometimes you get hackers who were on the bad side and then convert over. They would be called your gray hats. And in that instance, you would kind of limit their access to your systems just until you get a sense of, are they going to compromise your company or not? And then obviously your black hats are your malicious hackers. So yes, you do get good hackers. And in order to then know how to protect your system, I mean, it's many, many years of research. Security is all mathematics-based and logic-based. So in your training as a computer scientist, in your coursework, and as you go on to specialize, there is security built into your coursework, and it teaches you the foundations of what is security, how do you protect the system. So I guess in a way you do learn how they think, because they also have this information, but then they use it in order to compromise a system. So in computer science, you learn the same things that the hackers do, but then you use it to protect your system.
Wow, what a fascinating topic. Thank you very much. Well done.
Right, thank you very much. Of course, you shared with us some information around smart devices, TVs that listen and phones that watch. Kind of puts a new spin on that movie, I Know What You Did Last Summer. So thank you to all our participants, all our contestants. Thank you for sharing your science in an informative but also engaging way. So a special word of thanks to Onesimo, Ewura-Esi, Nompumelelo, Tanya, Nehemiah, Zahir, Tarryn, Johanné, Nolwandle, and then lastly, Lehlogonolo. Ladies and gents, we are back. The judges have had some time to think, discuss, debate, fight on your behalf. And before I announce the winner for 2022, I'm just going to briefly hand back to the individual judges to share some of their insights, please. Ina, if I could start with you, that would be great.
Thank you, Gillian. All I can say is, wow, what an amazing competition and event. What I've learned from COVID was that scientists shared with us that they never learned how to communicate their science to the general public. And I think through this competition, you create so much awareness around how important science communication is for the general public to understand why we need science. Lots of doubts have been created in people's minds during COVID, we've seen, because they don't understand the importance of science and what's behind the science. So I think this competition really helps to create more awareness, and more senior scientists can certainly learn from these youngsters. I want to commend and congratulate the organizers, FameLab, and all the participants and all the students participating in this competition. Well done.
Right, thank you very much, Ina. Tshiamo, if I can hear from you, please, some of your last words of wisdom.
So today, we've moved from the universe to the oceans. We've moved from the oceans to flowers in the mountains. We've slept, we've woken up and eaten. We've healed ailments, we've raised children, and we've even explored the human brain as well as machinery in their brains. Today has been exhilarating, and you have taught South Africa that science is not only broad, but it can be used to solve a multitude of problems that we face. I've learned so much from each and every one of you, and I'm excited about the direction in which your research is going. All I can say is, keep the light on science shining bright. Thank you to all of you for today.
Right, thanks for that, Tshiamo. Let's move to our science writer, Vida. Some of your last thoughts, comments?
Thank you very much for today. each one of these participants had a story to tell about their research and how it is important not only in South Africa, but also in Africa and on a global level. And I am inspired, and I want to say thank you to the organizers and to the participants for all the hard work that you've put in to tell your story, but most importantly also that the research that you are doing is so important and well done, and we're looking forward to the results. I want to say also that I think you are not only excellent science communicators, you are excellent communicators per se, and excellent and exceptional scientists as well, and all the best for your future. Thank you.
Right, thanks for that, Vida. And then last but not least, Sibusiso, your thoughts?
Yes, it's been a very exciting day today. I'm a science communicator. I talk to scientists all the time, so it's always quite interesting. I've heard so much, I've heard all the things, I've seen all sorts of amazing things, but it's still very encouraging to see and hear scientists so passionate about their work. I know that scientists spend a lot of their time doing science, doing research. So to see these young scientists have so much passion and love for their craft and the ability for them to communicate their science and even excite me, someone who does this for a living, I think it's quite amazing. And I would like to encourage everyone who's participated today to continue in their science communication journey. And I'd really love to hear more about their work going forward, and also to take part in communicating their science as well, as exciting as it is. Thank you.
Right, thanks for that, Sibusiso. And again, from my side, thank you to all four of you, judges, not just for giving your time, but also sharing some of your knowledge, your insights, and your learning and your experience as we grow the next generation of science communicators, people who are exceptional in terms of their craft and their gift, but who also have the ability to get the message across. So participants, thank you for signing in. Thank you for being part of the 10th season. And you, of course, today were judged on content, you were judged on clarity, and you were judged on your charisma. So our judges debated and they selected 3 worthy participants. 2 of you, of course, we would label as runners-up, and then we have the winner that will represent South Africa at the international competition in November. Our second runner-up for the year 2022, representing the University of the Witwatersrand and also the CERN, which is the Research Facility Switzerland, Geneva, we have Onesimo Mtintsilana. And she shared with us some fascinating stuff about matter and antimatter. So well done to you and congratulations again as being selected as one of our 2 runners-up. So our first runner-up then for 2022, tackling the problem of sleep disruption from the University of the Witwatersrand, Johanné Marais. Well done and congratulations to you. Of course, all of you are exceptional, and unfortunately there has to be a winner, but thank you for sharing your content with us today. And then it gives me great pleasure to introduce to you the winner for 2022, the person who blew away the judges with content, with clarity, and with charisma. And for the year 2020, the award goes to, from the Nelson Mandela University, we have Nehemiah Latolla. The guy who spoke about medicine and how we can take plants with a bit of chemistry and figure out how to improve the lives of everybody. Well done, and congratulations to you, Nehemiah, and thank you that you will be representing South Africa at the international competition in November. And again, a special word of thanks to our primary partners, NRF SASTA and Jive Media. So thanks for being with us, and thanks for celebrating science through the art of talking about what we do.